Hello, chemistry students. This is Mr. Rounds. We're in the chemistry lab over here at Holy Cross. My youngest daughter, Hannah Marie, is helping film this. This is a reaction that you've seen already, but we want to introduce a number of things, and I want to see how this goes. The chemical reaction, we're going to have some regular table sugar, sucrose C12H22O11. That's the white, that'll be the white crystal. We're going to pour some concentrated sulfuric acid on it, about the same amount, and that's the H2SO4. Those are the reactants, okay? Yield sign, and then the products that form, the SO2, that'll be sucked out of the fume hood, so we're not going to smell the sulfur. Carbon will be left, as you can see by itself, and there's going to be water given off in the form of water vapor. It's going to be real hot, so it will not liquefy. It will be in the gas state. So let's get going with this. So you see I've got a lab apron on. I should be making you wear those, so we're going to pull those out and get those going when you all get back, in case something spills on it. And of course you wear your safety goggles, so we're going to put those on. And since I'm going to handle concentrated sulfuric acid, I'm putting these gloves on also, okay? And back here we're doing the we're going to be using the fume hood, okay? You want to see what we're doing. So I turn the light on, and then I'm going to turn on the suction vent, which is going to suck air in, so any dangerous fumes created are going to be sucked out, up into the vent system. You can see it along the wall, all the way back there, and then it's taken out the side of the building. I used to think it went up to the roof, but it goes out to the side of the building there. So, in our chemical storage areas, besides the flammables cabinet, we also have bases stored here separately from the acids. This is the acid cabinet. And each of the different acids has a different colored cap on it. You see one with, this one's yellow. Hydrochloric acid has a blue cap. There's red. Anyway, so different caps indicate different acids, since over time, if any of the labels are corroded away, they can still usually tell what the acid is. Now, if it's real old, which I've seen some, that the yellow even fades away, and what's left is just more of a clear cap. So it's still it could be difficult to tell what that is. You have to do some more testing on it before you use it. You never assume anything. Okay. All right. It's a container of sucrose. This is the sucrose, the white crystal, just regular table sugar. This, of course, is a Pyrex beaker. It can handle a lot of heat. There will be a lot of heat generated. It is considered an exergonic reaction, which is heat given off, an endothermic reaction. Okay, thermal is heat energy. Endo is giving off. Okay, we use a lot of energy. We are exothermic organisms. That's why we have to keep eating and eating and eating. We take energy in. Okay, so I'm going to pour this very concentrated sulfuric acid. I'm going to pour about the same amount in here. About the same amount as the sugar. And then I'm going to take a glass stirring rod and mix it up a little bit better. Remember, glass is very non-reactive. You can see what was kind of left from before. That's what I had around here. Okay. Normally I'd be using a perfectly clean glass stirring rod. This was left from when I've done this before. That's what I'm doing. I'm not just putting any dirty thing in there. I know this is what's going to be left. So I'm mixing it up. It's already starting to get a little bit warm to my touch. Like I said, it's heat giving off reaction. And this is why I have the thermometer here. Sometime I'll do this and see exactly what the temperature is. Okay. I turn it so the blue symbol is away. And this is chemical reaction going on, so bonds are being broken Any covalent bonds between atoms being broken, atoms rearranged in chemical reactions. We see an actually fairly simple one going on here. It's neat. It's really, really cool. Well, I'll just let you watch and I won't do this, but this is one that you'll see why we need to do this in the fume hood. Okay. Yeah, there's more to it. Just set things that I'm using over here in this one. And we just keep watching, see some bubbles going on in there now and then. These atoms are rearranging and it's getting ready to go. Sulfuric acid is a drying agent. It's pulling the H2O out. There's sulfur dioxide given off also. And that's what usually stinks, and that's being, as you can see, it's being sucked out in the fume hood. Okay? So we don't want to be breathing these dangerous things. What's left? Sulfuric acid is used a lot in industry as a drying agent. It bonds to the water and removes that. So a lot of times they'll soak different metals in a weak sulfuric acid solution, okay. And everything. So it's pulling the H2O out, and the only thing left is the carbon. Okay. So carbon is just a bunch of carbon atoms. The color from that is black, like a piece of coal. The rubber on a tire of an automobile is black colored. Okay. It's a pretty cool reaction on it. I should say cool because it is extremely hot. In fact, I'm going to stick the thermometer in now and just see what the temperature gets up to. The room temperature, so obviously this is from before, but the room temperature, ooh, it's going up fast. See the bulb on it? This is already up to, 110. And room temperature in Celsius was about 22. So we're already over 120. Should be up around 130 right now. That's where this anti-roll bar is. This triangle thing is there, so if you set it on the table, it won't roll off. Okay. Up to getting close to 140 and slowing down. If it gets up further, I'm going to take this out of there because I don't want it to burst on me. So about 140 degrees. Wow, lots of heat. And so this would be very, very hot to touch, even with the gloves on it. So we don't do that. We'll just leave it alone for a little while. Okay? But pretty cool reaction on it. So this is the first one where atoms react. Tremendous amount of energy is stored in covalent bonds. A whole lot of energy. So this is just kind of an example of that. A real cool thing to see. And we're going to do more with this, which is one reason I want you to see this again. We have some reports that we need to write up, and you can always flip back and see this thing. So, thank you very much.